Hi, so let's talk a bit about how images are formed. So we're going to look at the most basic example of an image formation onto a piece of film. So imagine you're outside in a park and you're holding a strip of film while facing a tree. So light reflects off the tree at different points and bounces off the tree onto your piece of film. So as you can see in this example, what happens here is that the top of the tree and the middle of the tree are going to reflect at similar points along the film. That's not good. That will actually that will basically result in an unfocused image or blurred image here. So as we can see, that's not how our eyes or cameras work. This is a better example of how our eyes and cameras work. We essentially use a barrier to block off most points of the light while leaving a small gap here, and that gap here is called the aperture. And this allows just some points of light to be reflected onto the film. So this gives you a much more focused image, and it's actually the basis of a pinhole camera. So there is a problem with this simple pinhole camera model in that the aperture is always fixed. So that means that a constant amount of light is always entering this hole, which can be sometimes overpowering for the film, meaning that everything is going to look white. And secondly, we can't focus using this fixed aperture. To focus the image even better, although it's never going to be as bad as the previous image, we still need to move the film back and forth. And that's not really a good system. So how do we fix this? Well, by using a lens. And an adaptive lens, which is what most modern cameras and our eyes use, it allows us to control the aperture size. And in photography, aperture size is referred to as f-stops in cameras, and lower is better. And also lower allows us to get some nice depth of field, which is also called bokeh in photography. Just so you know, bokeh is a highly desirable trait in photography. It allows us to have very blurred backgrounds while we focus on a foreground image, resulting in a pretty nice effect. Secondly though, with using a lens, you actually can control the lens width, which allows us to, instead of moving the film back and forth, we actually use the lens to focus it directly on this point here. This results in a very nicely controlled system. So firstly, before discussing how computers store images, I think it's good to discuss how humans see images. And if there's one thing you should know, humans are exceptionally good at image processing. Starting with our eyes, they're remarkably good at focusing quickly, seeing in varying light conditions, and picking up sharp details. And then in terms of interpreting what we see, humans are exceptional at this, as we can quickly understand the context of different images and quickly identify objects, faces, you name it. We can actually do this far better than any computer vision technique right now. And our brains do this by using 6 layers of visual processing that you can see here. I won't go into the details of this, but it's incredibly complicated. And if you're curious, you can visit the Wikipedia page on our visual system right here.